people will still come trickling in, but that's good. We have a great panel in store for you now. So cloud native applications have revolutionized the way that we develop, deploy, and manage software. And as organizations are increasingly embracing cloud native architecture, it's becoming crucial to explore how to effectively manage these applications while also considering those trade-offs and just maximizing the benefits out there. So here to introduce and moderate our panel of experts as they delve into these challenges and strategies for managing cloud native applications, please welcome to the stage Principal and General Manager at Techstrong Research, Mitch Ashley. Give it up for Mitch.
Everybody, welcome everybody. How about a big round of applause for Michelle? Keeping things rolling on time here. Great. I'm going to introduce our panel. We've got this listed up here. We're going to be talking about cloud native, and we really tried to put together some diverse perspectives. I think you'll find that pretty quickly here. First coming to the stage is Aja Hammerly. Aja is Developer Relations Manager with Google. She's been at Microsoft, Expedia, all kinds of great companies. Thank you. Well, let's hear a round of applause for Aja. And next we have Tara Hernandez. Tara is VP of Developer Productivity. I got this wrong on her streaming interview with MongoDB. She also has Mozilla, Netscape, Borland, Pixar, a whole bunch of, if you've used Bugzilla, she's touched a lot of and created a lot of technology we've all used. How about a round of applause for Tara? Last but not least, he's almost a newly minted author, maybe about a month or so away. Adam Robertson is head of DevOps at Engage AI. He's also writing a book on cloud native, but not just what is Kubernetes, but how do you really architect and grow and build. So he's perfect for this panel. Thanks for joining. All righty. Oftentimes when I'm having a panel, we're talking about a topic. You know, we love to create new terms, and then we like to change those terms to mean whatever we want them to mean. That's pretty much what makes our industry go. So it may sound rather academic, but I'd like to create a kind of a working definition of what we mean by cloud native. So maybe Aj, if you would go first, I'd love to hear your perspective.
Yeah, so my definition of cloud native is actually pretty simple. And for me, cloud native is any sort of development process, software delivery process that uses the container as the primary software artifact. Because there are a lot of modern practices that go along with cloud native, but those are modern practices that could apply to other architectures, VM-based. But for me, the thing that makes something truly cloud native is that it's based around containers as the thing that you pass around, the thing you deploy, the thing you build to.
I like the other definition that you had too.
Oh yeah, modern development is whatever development practices I wish my team was using.
I think that's worth calling out. My definition is a little broader, which is any type of technology that is arbitrarily deployable, like think of an infrastructure as code model. Containers is obviously a very, very natural artifact of that, but I don't think we should ever limit to just containers, especially given the slow adoption rate of containers. So it's like the redeployability and the adaptability and expansibility, if you will. So stateless for growth, horizontal scaling, high availability types of things. All the things that go into that type of topic, I think encompasses cloud native.
And I think agree with all that. I would also say the ephemeral nature of it as well, being able to, the repeatable and ephemeral nature of anything from it being a container itself doing scaling or from any kind of infrastructure or applications as well, which allows for a lot of things like fault tolerance and self-healing and repeatability, scalability, all the other buzzwords that come along with cloud native. So,
the two definitions I run into most often are something is built that uses cloud services, right? It operates it. It's natively built in the cloud. The other is it's kind of the Linux Foundation CDF definition of microservices, containers, serverless, open source, maybe a few other things. What do you does that definition serve us well? Because none of the three of you use that definition. I'm going to ask Tara to go first because I know you'll have some insights for us.
I don't know if I have insights. I certainly have opinions. So we touched on microservices. I think that's an interesting, let's call it an implementation detail, right? And And I remember when Sam Newman was going around touting about this back in the day, and others who have talked about it. And I think it is an interesting aspect if you have the right type of application and you can benefit from it. But I can also say that any solution that you choose also is going to come with a certain amount of rope by which you can, accidentally hang yourself. And one of the things that I have noticed quite a bit and have discussed with friends in the industry is that microservices is also a way to get you in a really bad state for dependency management, right? It's like, oh, now you have 1,200 repositories, each of which has like 300 dependencies, and your Dependabot chores suddenly are, a third of your profit margins. So I think it's really anything that is a specific type of technology or a specific type of architecture really needs to be understood within the context of what it is that is, your business value. I don't think there's a one-size-fits-all for anything in modern industry.
Adam, you really emphasize the ephemeral nature of being in the cloud. Why is that so important to cloud native?
I think it generally is kind of a foundational element for a lot of the other important things. Like I mean, by definition, all containers are mortal, right? And that's by design. For the fact that you can scale up, scale down, it's portable. You can change it to any cloud provider. You can run on your laptop. You can run it on your bare metal. So something you said in the very beginning, or just a few minutes ago, was anything that runs in the cloud is cloud native. Well, okay, but also I can run that on my laptop, and I can run it on my data center, and I can run it on a Raspberry Pi. So as long as you understand the cloud native principles and use them as your guiding light, where you actually run them doesn't matter.
Great. Naja, you emphasize, I'm coming to you with this question. You emphasize containers.
Yeah.
As kind of a central theme around cloud native. Why?
So I don't think it's the only way to do it, but if you look at the technologies that are championed by the Cloud Native Computing Foundation, if you look at the things that we talk about when we talk about cloud native, containers seem to underlie a lot of it. Could you do a cloud native situation that way? But I did my first cloud migration a very long time ago. I'm not going to actually say how many years that was. There was nothing about that migration that was cloud native. It did have auto scaling, but we were just taking stuff off the servers that I had racked and putting it into a cloud because it was cheaper. And the auto scaling was sort of auto scaling. There was nothing about that that was cloud native. Now, if I work on a cloud native architecture now, containers give me that flexibility. Oh, I want to run those containers serverlessly? Cool, there's a dozen ways to do that. Oh, you want to run those containers on VMs because that's a particularly useful thing for your application? Maybe you need a specific chipset, I don't know. Okay, you can do that. That container object is what gives you the flexibility. It forces you to build that ephemeral thing. It forces you to handle a situation where you can't necessarily always keep state in an easy way, although I know people do keep state with containers now, and
Don't do that.
that's some magic. No, I've watched several talks on it. I'm like, wow, that's a lot of work. I wonder why that's a good idea for you. Because it must be, but it's still a lot of work. And it all ends up coming back, and maybe my employer is showing some of my bias here, but it all ends up coming back to that fact that we have these artifacts that enable all of these other things. Can you do infrastructure as code with VMs? Heck yeah, I've done it. Can you do auto scaling on a VM cluster? Okay, sure. Can you do stuff that doesn't actually appear to have containers but might be backed by maybe non-Docker containers under the hood? Yeah, there's lots of people doing that too without realizing it. But it's that portable, open standard object that has all of these different technologies built around it that I think is the hallmark of cloud native computing.
Fundamental packaging and distribution, right?
Yeah, it's the currency. It's what we move around and what we build things out of.
And the architecture,
Yeah.
I think. So like microservices we were talking about earlier, that could be a good idea, but the concept of a macro service, whatever, it's really driven by what is the unit that you wish to be able to update when the 15 CVEs hit that will allow you to update just, that much and no more in a same way, right? And how much of an API layer, boundary do you want to be able to maintain across the various functions? And what is even cloud anyway? Like a lot of us, for a long time, I thought cloud meant either AWS, Google, or Azure, and now Alibaba and Tencent and Oracle, and everybody's got the cloud. But then there's also, on-prem, right? And
Private
so
cloud.
there's so many nuances to this.
Yeah, hybrid, private cloud.
Yeah.
All of those things have some of the advantages of cloud and have their own unique strengths.
I would add a little bit to that as well. It's just, everyone talks about this container like it's the smallest thing. And it's just not, as easy as everyone thinks. Like, if you go into an organization that isn't cloud native and try to make a migration, you have to understand that you have to educate a lot of people on what things like container architecture is, like what the best practices are, because everyone, and I think everyone here has probably seen it, but they're like, sure, we'll containerize it, and they literally lift it, put it right in there. You're like, no, not quite.
6 gigabyte container size.
I've had 30, yeah,
All
and it's,
right.
yeah, and they're very
Let's
proud.
run gripe on that.
Yeah,
Oh yeah, no, the magic of can I put it in a container? Yeah, you can.
you can. And
It
then,
doesn't matter what it is, whether it's Fortran or COBOL or, yeah, no, it all
You can
goes.
put a .NET monolith application
Hey,
in a container. It's been done.
monoliths have a role. They are not necessarily bad.
there's the time and a place for everything, yeah.
So let's jump to, the hype and reality of cloud native. What are the real reasons to do it? I mean, we talk about, if you kind of follow the dogma of it's an architecture for applications, I mean, it has to be microservices, has to be Kubernetes orchestration, containers. Why do we want to use this kind of an approach, thinking of it the way you define it? Adam, go ahead.
Sure. I mean, advantages tend to be, well, you also have to classify it from a business perspective, right? You can think about just the rapid, deployment and the packaging, and that comes along with it. So your, engineering velocity increases and all the things that come, the benefits are there, but also developer enablement, right? If a container runs locally, they're able to push it out anywhere. And so just the general operational and business, benefits are far outweigh any that I've seen thus far. But also just, it's one of the things I've seen to where it gives people something to unify on. And if everyone's on the same page, they can independently develop and work together. And no matter who it is in the organization, as long as they're following that same pattern, it's going to work with everyone else's for the most part. So, you have the kind of culture of, okay, designing it locally in a container image that makes its way all the way up through the development life cycle. And that just makes for very seamless, very fast. There's a right for automation, and just generally allows engineers to focus on writing code, not the other 70% that they spend their time on.
Jump in.
So obviously everything you said, and I was sitting there thinking, how do I put in words? Because for some of this, it's just feelings for me. And I'm gonna go with an analogy. Be patient with me. So like, if you've ever moved, it is way easier to pack the truck if you put everything in boxes, because the boxes stack on top of each other. They're about this, they come in a limited set of sizes. And having managed services that weren't containerized, having been on call for them, having built several, even when you did break stuff down into different microservices or different pieces that were owned by different teams with different dependencies so that you could do the rapid development in series or in parallel, you still ended up with 5 things that were 5 different shapes that you had to put into your production cluster. And you had to figure out, okay, well, this thing needs these dependencies, and this thing can't run next to this thing because they have, dependency conflict, or, this thing needs this particular version of the OS. And the reason that I am super into cloud native technologies is, the flexibility, the ability to horizontally scale, all of that is great. The fact that everything, when you're going to deploy it, is roughly the same shape gives you all of those abilities. It gives you the ability to bin pack on a cluster and actually use it to its capacity. It gives you the ability to know that you can scale out on a variety of different machine sizes as long as you can put your containers there, put your artifacts there. And that's magic. Like, I know that it's not new at this point, but I'm still kind of enamored with the magic that gives us.
So I have worked for a company that I will not name. And to separate from what Google does, because Google does this legitimately. But this company, what they did was they had a software architecture and a data store that required there to be a minimum physical distance between the application servers and the database in order to meet their performance requirements. Okay? So how we racked the hardware in the data center became a critical business need. And what does that prevent us from doing? What every company needs to do, move and scale, right? So I think that, to me, what you said, absolutely, like make the packages conform to a reasonable constraint of size, but also think about, like, it, going back to what Adam was saying, is it about, it's turnaround time, right? You start out, like, in the garage, and your customers are within 100 miles of you, and that's all well and good. That's no longer the case. Globalization is now firmly with us. Like, I myself have an organization that spans from Sydney to Berlin, right? A lot of us here probably go all the way to Bangalore. I did that while I was at Google, right? We are worldwide. So you cannot do that without some form of cloudification, which means we have to be thinking in terms of what are the software architectures that enable us to do that as a default standard, right? That is the business that we're in. If you want to be truly local, you're probably not in tech anymore. You're running a bar, which some days sounds really good.
Adam and I were talking earlier in another venue about about resilience, and your story reminds me. I did a broadband network deployment and had an engineer tell me one day that the DS3 card had to go into slat 3 on the switch. I said, no, it goes into any one. Why are you saying it's slat 3? That's what it's always been. I said, it's in slat 3 because that's how long the coax cable was on the first deployment. So it became the standard. So always challenge your assumptions. So let's talk about, what it takes to really adopt cloud native. Like, where do you get started? If you're telling people you have to design, microservices for your application, how big should they be? How do you make it what really is an atomic microservice that truly is standalone? Or maybe it's more the infrastructure, right? How do you build the underpinnings of this? I'd love to, Aja, if you would start, where would you recommend people getting started? Assume they're not doing containers or a lot of these things first.
Okay, I think the Dora team would prefer that I say wherever feels good. Start somewhere and baby steps.
Just start.
And
Yeah.
measure it, have telemetry.
Measure it. So I'm actually going to say that there's a dev book that I really like, Working Effectively with Legacy Code by Michael Feathers. And one of the things that it talks about is if you don't have any tests, you put in integration tests that characterize your system, even if they are testing incorrect behavior, so that you know if you change something. And if I was going to take a team that that was starting on their journey, the first place I would start would be making something repeatable, whether that's their testing infrastructure, whether that's their provisioning. Maybe they don't have source code. That would be a great place to start. Maybe they need to do an automated CI/CD so they can start deploying multiple times and deploying to different environments without having to, work through the 75-step deployment guideline that I totally never actually had, doing it all manually. I would pick something that they're doing manually in their process and start by automating that and making that reliable and repeatable, even if they know that what they're currently doing is not the end state they want, and then iterate from there. But pick a thing and make it repeatable.
I would build on that. Identify a thing that is functionally contained. Like in a lot of monoliths, there would be like, account management, for example, how you your user management, or maybe it's the billing system, right? Extricate it, right? And here's a really good one, to make sure that you're not like dragging along some direct like bad behaviors, switch the languages up, right? So if you've got a Java monolith that you've been running for 15 years, hey, pull out the account management system and put it in Rust. Like, there's going to be like, or Go, or, pick a language. Rust, because that's a current joke at my company. Because that's going to force you to encapsulate what are the abstraction layers, where's that contract boundary that you need to create in order for that thing to truly be successful as a standalone. You're not going to have any lingering Java tendrils that are crossing inappropriate boundaries through the magic of class path if you do things like that, right? And so I think it's make certain decisions that, maybe are a little bit silly, but that actually in the long run, it actually solves two things. One, it's a forcing function, and then two, you have developers who want to learn new things, right? We talk about the tech. We always talk about the tech, but the cultural element is also super critical, right? Also a shout out to Dora, right? It's not just about the technology. It's about how do you inspire and incentivize your engineering team to up-level, right? So I think there's lots of opportunities when you're looking at re-architecturing and decisions that you make. Maybe like going to Go or Rust isn't actually the most critical thing for the business, but it's a long-term investment in your engineering organization that is also going to pay off in an interesting way.
Rewriting the accounting system over the weekend's not my idea of fun, but okay.
Hey,
Even if I want to.
I don't judge.
Rust has a really small learning curve too. It's really fast. I would add on to that. Just when I was at Pinger, we did exactly this. Everything was on bare metal, and we decided we were going to put everything in Kubernetes. And the way we decided to do is get the lowest hanging fruit, the most containerized, easy thing. It was a stateless web application, and we were able to move it in 3 months. And the amount of things we learned in that 3 months was we're able to make the following next one be 1 month, right? And so, take the one with the least amount of unknowns and the simplest. If it's just a simple web page, man, that's easy, and you just learn so much. And also, don't be afraid to assume that you don't know anything about it, even if you've done it before, because there's surprises that are going to pop up you've never even thought of, and be open to that and plan for that on your timeline.
So I would propose that cloud native is not an end state. It's a process you start through your development, from the very beginning of designing software through how you design it, thinking about Jenkins and Cloudbees and things like that. Describe what do you need to do to adapt your development work, your development tools, workflows, et cetera, to really be successful at cloud native. You have your mic in hand. You're like ready to fire. She's ready.
Well, we touched on this a little bit earlier in the interview, which is you have to create an understanding of why it's important and use that to inspire and incentivize your organization. You can't say, hey, we're going to do this cloud native thing, but here are the 15 product features that we have to hit in the next 90 days, right? Why even have this conversation? I've been involved in customer engagements where, the whole engineering team's like, we've been trying to do this DevOps thing a couple of times now, and it's just not landing. And then the executives come up and like, oh yeah, we're really committed to this. And oh yeah, we're really committed to that. And then the sales VP comes up and says, but we need those things, right, for these customers and before that, before reInvent. And like, you got to stop right there, right? It is a matter of business investment, right? And treating the infrastructure investment that you need to make as far as how you do software development, how you do architecture as a business critical need, and schedule it, and then reward people who innovate. It can't be an afterthought, and I think too many companies will kind of lean into that mistake.
Got some support there. At least one person.
I'm
has
hiring, by the way.
experienced that. Nobody else in the room has experienced that before, but one person has.
We've all seen it.
Go ahead, Al.
I would say, yeah, just buy-in, making sure that all your stakeholders are on the same page and getting people excited about it, because it's work and it's a different shift in thinking. And if anyone has ever asked an organization to make a big change, they know the answer is resoundingly no. Why? They always start with no, and then they ask why. So small incremental changes to where they can kind of maybe, they're not so afraid of making those changes. And then they look back in the previous 6 months and say, wow, we've made a lot of changes, and now life is a lot better. And they're just like, okay, this is not so bad. There's a race called the Iditarod in Alaska, and it's thousands of miles for Huskies to run. The person or the team that wins it is when everyone's in line, everyone's excited, and they're all going, they're pumped and excited. You'll never see anyone read it, or any team win that when they're sitting there dragging their Huskies, because that's just not how it works. So if you want your team to finish, at all, let alone first, you have to get all your ducks in a row, get everyone on board. The strongest motivators I've seen are find those ones in your organization that are on your side, make them evangelize it, right? You're not the one telling everyone, hey, this is amazing, because you have someone in that team telling all their coworkers, hey, this is amazing because, and then all of a sudden, that person has a lot more credibility within their team than you do. And then everyone's like, okay, well, if Mark, thinks this is the right thing, let's give it a shot. And it's much better than, hey, this DevOps guy who's trying to change everything that I'm used to, right?
You just said a dirty word. There's no such thing as a DevOps guy. Come on now.
That's the next panel. Okay, Aja, why don't you wrap it up?
So everything they've said, they hit all the big cultural points, and as we all know, a lot of this stuff is a cultural journey. So I'm going to just give some practical points on change as a manager, which is figure out what's going to be hard. Where are the sticking points going to be for your team, your code base, your company? I'm going to pick on one because this is a thing that I have been just bothers me for the last 25 years. HTTP is supposed to be stateless. Who would have known? So if you're holding state around, if you're being messy with state, that's going to be a challenge as you move to some of these containerized systems, these microservices, these systems you need to scale globally and horizontally. So look for things like that in your code base. Look for the people on your team who don't understand some of these things, and they've been getting away with maybe, I'm not going to call them bad habits, but effective uses of shortcuts the last 10 years. And then think about who's going to be the person who's going to throw the biggest fit. Whether that's a manager, someone who's been around for a while, someone who's brand new and is just really nervous that they don't know enough to make the change. And simultaneously think about who is going to be the best of your champions. You mentioned finding your champions. And start working on both ends of the spectrum simultaneously, get your champions involved, get them talking to their peers, and also start working with those folks who are nervous and figuring out what they need to feel supportive and successful. And once you do all of those things, it doesn't matter what the change is, whether it's DevOps or, new management or, moving to a different type of product. Those are the things you need to do to move the team forward.
And just to wrap it up, I want it to be known that we went 30 minutes without mentioning AI. All right. How about a round of applause for a panel? Is this helpful? Talk about some very knowledgeable people. Thank you for joining us.
Thank you.
So,
Thank you.
Michelle, we'll turn it back to you.
Thank you. Excellent job. Thank you so much. Yes, Mitch, Aja, Tara, and Adam, excellent. Terrific panel, great insights. We could go on and on with each one of these. Let's move on. Intuit is a global technical financial platform serving so many customers worldwide. TurboTax, Credit Karma, what else? QuickBooks, MailChimp is who they serve. So it goes without saying that they know what it takes to run Jenkins at scale on Kubernetes. So let's get a peek behind the scenes as the next speakers share strategies to improve overall availability across Jenkins controllers, while also reducing bootstrapping time by more than 90%. So please help me welcome the next three speakers: DevOps engineer Mike Now, software engineer Rekha Ajenthan, and senior engineering manager Vijay Agrawal. Come on up. All right.
So excited to be here with you guys today. Really excited to kind of share our journey at Intuit around Jenkins. It's been a long road for us, and we're still on it, but hopefully you can kind of learn something from the presentation. I'm here with Vijay, our dev manager, and Rekha, our staff engineer. I myself have been at Intuit for the past 16 years. I know it doesn't look like it. I'm only 25, but it's been a while. I started off way long ago as an SCM engineer, for those of you who remember those titles, transitioned through DevOps to SRE, and landed on the Intuit Build platform team, which is our team, about 6 years ago. It's been a fun ride. Today we're going to cover a few different things. I'm going to go over an overview of the platform, some general capabilities and the architecture. Then I'm going to turn it over to Vijay to walk you guys through some of the improvements we've been working on lately. And finally, Rekha will bring us home, working through some of the automated job lifecycle management processes we've been investing in. So the Intuit Build platform supports everything at Intuit. This is the commonly known applications, hopefully you're familiar with: Credit Karma, QuickBooks, MailChimp, TurboTax, but also everything internal as well, thousands of applications. It's multi-platform, supports all the major platforms. That includes Linux, Windows, Mac OS, and from the mobile perspective, Android and iOS. So today we have over 6,000 developers on the platform. It consists of 200 independent Jenkins controllers, over which we have about 400,000 Jenkins jobs. Rekha will go in later, kind of the work we're going in to drive down that job count to hopefully on a go-forward basis. The platform executes on about between 1,100 and 1,500 nodes, depending on the demand at the time. So in terms of builds, we execute over 100,000 builds a day, and that breaks down to about 90% of which are Linux, 9% are Windows, and the remaining 1% are Mac. We upload over 30,000 artifacts per day across different paradigms with Docker containers, Maven artifacts, NPM packages, and such. One of the key metrics we really like to focus on is our build queue wait time. And we define our build queue wait time as the amount of time it takes from the time a build is triggered to it actually starts running. And one of the metrics we want to hit is we want to be under 20 seconds for 90% of the builds running in the platform. All right, let's look at capability. So we run a platform managed Jenkins controllers is kind of the way we think about it. And what that includes is we do upgrades across those 200 Jenkins controllers. We install a base set of plugins, so we have consistency across all those controllers. Authentication is tied into Intuit's single sign-on process using the GitHub OAuth plugin. And finally, all of this runs on a single Kubernetes cluster shared across the entire platform, which our team operates. All right, so multi-platform support is implemented using the Jenkins Kubernetes plugin for Linux and the Jenkins Amazon EC2 plugin for Mac and Windows. And we support something called standardized job creation via Intuit Paved Roads. That's an internal thing. What that really means is templatized starting points for all the different types of projects we create, whether that's Java services, Python services, Go services, serverless apps, web plugins, you name it. We have templates for all of those. And that templatized starting point includes all the basic building blocks required to get started. Your GitHub repos, your artifact repos, your Jenkins pipelines, your runtime environments, and so on. All right, so across the ecosystem of controllers, we delegate admin access to trusted users on a per controller basis. And these admins are in charge of installing any additional plugins that are required, configuring some credentials, adding shared libraries, tweaking configurations on behalf of the user base of those controllers. And finally, operations, visibility. We push metrics into Splunk, Wavefront, and CloudWatch primarily, and we've built several dashboards that are available both to our users and our admins to kind of introspect what's going on in the platform on their behalf, and users are also empowered to create their own dashboards. All right, we talked about paved roads. Here's what a kind of standard GitOps pipeline looks like at Intuit. Pretty simple. Developers are committing to their code repositories. That will trigger a Jenkins pipeline, which will then build and test that code. And assuming everything passes successfully, artifacts are uploaded into our artifact repository. Upon success, then that CI pipeline will then make a commit into the deployment repo associated with that Jenkins or with that project. And essentially, it's updating the tag for the Docker container, let's say, that that project's producing. That commit will then trigger Argo to push and deploy that new Docker container image into the various runtime environments. And this is happening thousands of times across the platform on a daily basis. All right, let's look at the architecture. So the platform is broken down into a control plane and a data plane. The control plane is responsible for things platform-wide, and it consists of several different components. Some are off-the-shelf components, things like an Nginx ingress controller that just provides HTTPS access into the cluster and the Jenkins UI. An artifactory proxy, which caches artifacts in cluster, so that speeds up artifact downloads for builds. And then we also have some custom components we develop and maintain ourselves as well, one of which is a Jenkins CRD controller. CRD standing for Kubernetes Custom Resource Definition. Now, all of those 200 Jenkins controllers that run on our platform are represented as a Jenkins CRD artifact within the cluster. And that artifact just describes the Jenkins runtime. It describes things like the ingress entry point for that particular Jenkins UI within the cluster, the resources that are allocated to that runtime for Jenkins, the CPU, the memory, the disk space, and so on. And it's the responsibility of that CRD controller to manage all of the Kubernetes resources associated with that Jenkins controller in the data plane. We also have a few other things in the control plane, some cron jobs and daemon sets. So let's switch over to the data plane. So within the data plane, this is where all of the actual Kubernetes resources reside for the Jenkins controllers. Now, each Jenkins controller runs in a dedicated namespace inside of the data plane. And we have 200 Jenkins controllers. We have 200 namespaces in our data plane, each representing one of those Jenkins controllers. Now, we went with a dedicated namespace approach to help effectively manage these Jenkins controllers independently when we need to. Now, a good example of this is just kind of that noisy neighbor syndrome. Remember, we're running this all in one shared Kubernetes cluster across the entire ecosystem. So we want to prevent, say, Jenkins 1 consuming all of the available capacity and impacting the other 199 Jenkins controllers. So what we can do is we can set namespace level limits in the cluster to prevent that from happening. So that's just one of the examples we can do and pull from that perspective. Outside of the cluster, we use GitHub Enterprise for source code management. We run our own JFrog Artifactory server for artifact management. And from the deployment perspective, most of our Kubernetes deployments are all done via Argo, and everything else generally goes to AWS directly. And now I'm going to turn it over to Vijay to talk through some platform improvements we've been working on.
Hey guys. Hey, this is Vijay. I joined Intuit a year back. Before that, I worked at a couple of startups and Microsoft, building Microsoft Teams. Here, I'll talk about some of the platform improvements we have done over the last year. And some of those improvements have been one of the goals were improving the resiliency. As we saw in the keynote as well, resiliency was one of the big challenges that we were facing, because Jenkins, as we saw in the architecture, is centered to all of the services that we run, and a lot of automation is built, which is critical. Like if somebody needs to switch to DR or needs to execute their HA solution, like that pipeline probably resides in Jenkins. So if Jenkins itself is not up, then it can become a challenge. So one of our main goals for this this part was improving failover and resiliency for that. The other part was we would restore from a cloud snapshot, which would, like in case of a HA event, so we would lose data. Like 15 minutes was our earlier RPO. So we wanted to improve that, and we wanted to ensure there is no data loss at any point on the platform. The other part of it was like we wanted to do faster upgrades. We were hearing from users that like our upgrades would causing a significant amount of downtime for them. So we wanted to have faster incident mitigation during incidents as well as faster upgrades. The other part of it was like we wanted to improve the utilization of our platform. There were a lot of builds, like this platform has been very old as on Intuit, like for 6 years, and we are seeing a lot of redundant builds being run, consuming resources on the cluster and affecting like healthy builds to run. So we wanted to reduce unhealthy builds running on the platform. We had a lot of stale jobs on the platform, so we wanted to see how we can effectively manage those lifecycle of that jobs. The other part was like for our team, we wanted to spend less time managing the infrastructure. We wanted automation in place to manage that infrastructure for us. And overall, of course, the last goal was improving the developer productivity for all of it. And one of the main goals was how can we reduce platform-generated requests for users. Like any request that we generate as a platform kills the time of the developer to actually perform their application code. So we wanted to reduce that. And the other part of it was we wanted, obviously everybody loves faster approvals, right? So we wanted to improve how can we improve our approval rates. The other part was like we wanted more performant Jenkins controller for controllers that were overloaded. And we were seeing like some UI issues on controllers where there were thousands and thousands of jobs just for the UI to work effectively. So we wanted to improve that experience for developers. So we'll look at how we achieve that, and for that, like we will go over this architecture in very brief detail here. So the point that I want to highlight here is like for each of these Jenkins controller, which runs in their namespace, as Mike mentioned, they are backed by a EBS volume on AWS. And EBS volume is, while it's highly performant, the restriction with it is it works only in one availability zone. Like you don't have replication across another availability zone. So when you need to spin up a Jenkins controller in another availability zone, you need to download from a snapshot, which in our case used to take hours because our controllers were few TBs. Some of those were like huge overloaded controllers, and it'll take hours for us to do that process while the controller is down effectively if you want to do that failover. So how did we mitigate it? We'll talk about it. So this is the architecture that we came up with. There is a solution we leverage for is called Portworx. It's a pure storage by Pure Storage, and what it does is it provides us the ability for us to replicate volumes across availability zones. And with it, like we run two clusters. One is the storage cluster, and another is a storage-less cluster. The storage cluster manages all the volumes within our control plane. And it provides us replication. Like in this case, you can see Jenkins controller 1 volume whether is mounted to PVC1, where it is actively replicating to availability zone 1 and 2, and same for 2, which is replicating to availability zone 2 and 3. And all that is logical separation of volumes. Like it's not actually physical. EBS volume is abstracted away from the cluster, where we only deal with the logical volume. So one of the advantages of it is we can do auto demand scaling of volumes as well. We can have autopilot rules configured to provide us automation to increase or decrease size of Jenkins volume. Again, we run Portworx as an add-on on our cluster on each of the nodes to manage those EBS volumes. So at a high level, we'll see, let's simulate a AZ failure here. Like when, let's say AZ1 failed down, so our PVC1 and Jenkins controller 1 went down. And what would happen is now we have an active volume sitting in AZ2, which is already warmed up and preloaded. So Jenkins controller 1 Kubernetes will automatically spin up a controller in AZ2, which can come up within like 5 minutes or 3 minutes or 4 minutes instead of like hours that we were looking at earlier. And it provides us a very fast failover mechanism when something does go wrong. So after doing all this work, what our improvements were? Previously, like we were seeing up to 90 minutes for our larger controllers to fail over, and we're seeing like almost 15 minutes of data loss when we actually failed over. Like anything done in last 15 minutes, we would lose that data. With this solution, we are seeing like within 5 minutes, we are able to actually fail over, and we don't see any data loss because we are actively replicating. The other part of it is our upgrade times went from 90 minutes to 15 minutes. Our windows went down, like we would, every other couple of weeks, we will have to do AMI upgrades and stuff like that, which would take like 90 minutes downtime. Now, like that downtime is 15 minutes, and we are working to reduce it further. Another example of it is like previously, like if somebody installs a bad plugin, then we need to sort of restore an older configuration for that controller, and it used to take hours. Now that can be done because we have active copy. We can actually do that much faster with local snapshots. That's a capability that Portworx provides, where they on node store snapshot copies, which is way faster than downloading from cloud. The one other advantage we got from it is we used to do manual storage management. Like a lot of times, like users will keep on creating jobs, and at some point it will happen that the controller would be 80% full, and then we'll need to provision more storage, and it'll all be manual. We'll analyze. Now with Portworx, we can actually just configure autopilot rule, and that would actually do the increase or decrease, and it's all logical volume, so we are not actually paying the cost unless we use it also. So there is lot less friction. Other was like limited DR support. Our DR story was like we'll ask users to create a job on their DR cluster as well, and then sort of switch the actual job, and they would have to maintain 2 copies of the job. That was our sort of DR story before, and now we are working where like we would like just provide DR out of the box for them, and like with a predictable sort of SLAs for it. We'll see a brief demo of all this stuff in action. So here you can see the Jenkins controller is healthy. Now like it's running in US West 2A availability zone. So what we are gonna do is we are gonna kill both the instances, the storage less and the storage instance in there on that availability zone. And we will see that, so here we are killing both the instances on that availability zone. And as a result of killing that, we'll see the controller, we are simulating a easy failure. Successfully terminated. Now obviously the controller goes down as a result of it, and we are waiting, and after 3 minutes the controller is automatically back up without us touching anything at all, and we'll see the US West 2C automatically came back up and picked up the traffic to be served actively. So like from hours to minutes without any manual intervention. So that was the there were a couple of other enhancements we did on the platform. One was like we added a new tool in our arsenal called Build Sentry. This is again in-house build tool. What it does is it actively scans all the builds running on the platform every few minutes, and it reduces unhealthy or non-compliant builds. So if we see that a build has been running for more than 24 hours and like there hasn't been any input from the user on it, and it's just waiting for approval, or if it's been stalled, then we would go ahead and actually either abort that build or take necessary action to communicate to the user. And similarly, like whether it's duplicate builds for the same jobs, or if a build has been completed successfully but the pod wasn't reviewed by Kubernetes for whatever reason, that sentry would take action and actually clean up the process to get us the resources back. With this tool, we have seen like almost 25% reduced cost, and our infrastructure cost is huge, so that translates to a lot of savings for us. And as a side effect of it, because you are killing builds if users are not acting on it, so we saw a tendency that people used to approve faster because they know their builds will get killed if they don't approve it. So it resulted in faster approvals as well. And the main cluster auto-scaling worked for us because a lot of builds that we were running were like long builds. They would take anywhere from 7 days for approval, and while it's taking 7 days, it will occupy resources within the cluster. And even if a single long build was running on the node, it would prevent the auto-scaler from scaling down that node. So we were seeing like we were scaling up effectively, but we were not scaling down fast enough. And with this, once we kill those builds, if they have been long running or unhealthy, we saw the auto-scaler perform much better. The other part of it was we introduced platform policies on our cluster, and what that gives us is we can auto-correct build configurations. Like if somebody uses 1 TB configuration for their memory, we can auto-correct it to what the platform supports and provide a notification to the user that we are reducing it because platform only supports this, instead of failing the build or like failing the configuration itself. Similarly, like we can reserve resources for the cluster. Like for Portworx, we need some internal nodes or ports to be used within the cluster. So we can reserve that so that application space doesn't use it. Similarly, like automated handling of small changes. Like we can write rules where we say that when we are upgrading, we need this Docker image to actually be upgraded to this Docker image. So instead of modifying hundreds of Jenkins files where you have to send PRs to each of those repos, we can do it centrally. So it reduces times to roll those changes out from sort of days that it would take to hours, because we can do it centrally now. And it decreases like a lot of platform generated requests for our users. With this, I'll hand it over to Rekha, who will talk about automated testing.
Thank you, Vijay. Hi, everyone. This is Rekha. I have been with Intuit for 5+ years. Yeah. With that, let's start on automated job lifecycle management. So it is crucial aspect of the Jenkins platform that can significantly enhance performance, scalability, maintainability in the long run. At the same time, it accommodates job growth without impacting Jenkins performance, which makes it easier to maintain and manage in the long run. So here we will see the state of the Jenkins platform before and after implementing the automated job lifecycle management. As you can see from here, we were having 550K jobs in our platform, and it will come down to 225K job with a reduction of 60% at the complete rollout of automated job lifecycle management. But as you can maybe previously see, Mike was showing like 400K jobs at the moment. So we have been already reduced that much, but we are planning to reduce up to 225K job with the complete rollout of automated job lifecycle management. Also, we were growing at the rate of 30K jobs per month. So now, once we roll out the job lifecycle management, the effective growth rate would be 2K jobs per month, which means we will be actively cleaning up 28K jobs per month. And we were experiencing UI performance issue, especially in those overloaded Jenkins controllers. So once we roll out, the overall UI performance has been improved, especially in these overloaded Jenkins controllers due to like less number of jobs to manage. And we were experiencing larger maintenance overheads due to we had to like migrate or upgrade 560K jobs like at the time. But now it's easier maintenance because you just have to migrate or like upgrade only 225K jobs. Also, stale jobs are often outdated. They can pose security risk to the Jenkins platform. So due to this active cleanup, the security has been improved. At the same time, we ensured that these outdated jobs are no longer runnable in our Jenkins platform either due to accidental commits or periodic triggers, things like that. So in order to implement this automated job lifecycle management, we came up with certain principles and strategies. So the guiding principles are any strategies should not require any manual intervention at any point because we were managing 560K jobs. Also, in case of any emergency job like rollback mechanism, the job recovery should be self-served to the users so that our team does not need to get involved in this process at all. So the highlight of strategies are we were like kind of having 3 main strategies. The first one is job lifecycle management. So as part of this, every job will go through different life cycles like active, warning, disable, and archived. We will see more details into this in the next couple of slides. And the next one is discarding all the branches, PRs, and tags from the multi-branch pipeline. So this were having several other strategies, but one of the main one is like we are discarding the branches or PRs that did not have a commit from GitHub repo. We are kind of like removing those from the Jenkins pipeline. Also, we introduce discard all the bills as well as outdated folders. As part of this, we introduced retention policies for bills. So every build will be kept for only 1 year in our Jenkins platform. At the same time, we are recursively going through the build directory and throwing out any outdated folders. So here we will see the complete job lifecycle management, state transitioning. So any job will be treated as active initially. So if a job didn't have a build within last 13 months, that's when it will transition to warn state. So while it is in warn, if there is no further new builds for next 2 weeks, that's when it will transition to disable. So at this time, our automation has even disabled the job from the Jenkins. So if the job is kept disabled in the disabled state for next 2 weeks, that's when it will transition to archive. So at this point, our automation has gone ahead and even archived the job and kept it as a compressed format in the Jenkins disk. At the same time, it had even removed the job from the Jenkins runtime. So all these different state changes will be sending the notification to the job owners with the record details. And the archive jobs will be saved in Jenkins for next 13 months. If there is no further activities, then the job will eventually be permanently deleted from the Jenkins. So while the job is archived, what if a user needs a job? So if they need a job, there are a couple of options for them. They can either go to the Jenkins UI and unarchive it manually, or they can push a new commit to their repo. Both these actions will trigger the unarchival process, and it will bring back the job to the active state again so that they can start working on it. So this is the complete state transitioning of our job lifecycle management. And here we will see a short demo of all these state transitioning and the effect of nightly run on the job. So as you can see, a job had a couple, built last couple of days back, and since it's met the criteria, it has been marked as warning with a certain timeline when it will toggle to the next state. So in the next run, it has satisfied the condition, so it is marked as disabled, and at this point, it has even actually disabled the job from Jenkins controller. So in the next run, since in the timeline it met, so it is actually archived the job, and the archive jobs can be found from the shop projects folder in your immediate parent folder. So from this view, a user can go ahead and unarchive a job. So the user clicks on unarchive, so it should bring back the job to the original state again with all the build histories and all the configuration and everything. So that now the job is active, and we have even added a configuration to opt out from the automated job lifecycle management so that this job does not have to go through the lifecycle again since the user needs this job. So at this point, user has received a notification with the required details with GitHub repo and things like that so that they can take necessary action to either roll back or let it go. So this is all about automated job lifecycle management. So as part of this session, we have covered an overview, our CA architecture, platform enhancements, and automated job lifecycle management. So if you have any questions, please reach out to us in the break room. Thank you, everyone.
Thank you, Mike, Rekha, and Vijay. That was great. Thank you. I'm super happy to hear about these ideas. I think you are too. Excellent. Here's another thing to make you happy. It is lunch time right now. So there's 3 things you can do during lunch. You can either just eat, or, yes, we have a tasty meal for you. But we want to make sure you also catch some more time with the exhibitors and with each other. Also, we have another round of demo presentations going on throughout the lunch break. Those are little 10-minute segments. And also, we have more roundtable meet the speaker options for you to meet those speakers that you've just listened to. So yes, demo presentations, meet the speakers, eat lunch, and then we invite you to come back here at about 1:30. It's noon right now, so you have 90 minutes to do all of that, and we will see you back here. We have a great afternoon scheduled for you, so enjoy. See you soon.